Have you ever been walking down the street and someone's come up to you and said, "Hey man, what's cosine of 11 pi on 6? Exactly. And you said, "Oh, I don't know," and you sort of walked off with your tail between your legs. Well, by the end of this lesson, you'll be able to answer that question. So we're finding trig ratios rather, so sine, cos and tan of angles greater than pi on 2. At the moment we can just find them up to pi on 2. We want to be able to extend this all the way around the unit circle. So the idea is I've got this point here on the unit circle, because it has a radius of 1, which has coordinates of x and y, which means if I draw a little triangle around here with a right angle, this is y and this is x. So I want to know what's cosine of, say, pi on 6. So I'll use my trig rule, adjacent over hypotenuse. So from the point of view of pi on 6, x is adjacent and 1 is hypotenuse. Okay, so let's have a look. Cosine of pi on 6, x divided by 1 is just x. So cosine of pi on 6 is just the x coordinate of this point. So in these little conclusions, we're going to write the cosine of the angle is the x coordinate of the point on the unit circle. That's it. Yeah, I'll try to do a similar thing with sine. What's sine of pi on 6? Well, from the point of view of pi on 6, opposite is y, hypotenuse is 1, dividing by 1 gets rid of that. So I can do the same thing for sine. Pretty easy so far. And what about tan? Let's have a look. What's tan of pi on 6? Well, from the point of view of pi on 6, opposite side is y, adjacent side is x. Can't really do much here, but I can write that the tan of the angle is the y coordinate divided by the x coordinate. Another little interesting one while we're here. Okay, I could think of tan pi on 6 as being the y value, so sine pi on 6 divided by the x value, which is cos pi on 6. Yeah, but that's just for your interest. We'll look at that later on. So that's pretty cool. We've got those 3 facts established. Let's use these to try and find trig ratios of angles greater than pi on 2. We're going to do this first is to be able to complete this diagram using those 3 facts, that cosine is the x coordinate, sine is the y coordinate, and tan is y divided by x. This is a unit circle. So what it means is that the radius of this circle is 1. So I should be able to go around this circle and put in a few points. I know this point is 1, 0, this point 0, 1, over here -1, 0, and down here 0, -1. Which means just by doing that, I've already found some trig ratios of angles bigger than pi on 2 radians. So for example, what's sine of pi radians? Well, I know that's the y coordinate, and here we go. The y coordinate at pi is 0, and I can verify that on my calculator or whatever you trust has the right answer. Okay, similar thing, cosine 3 pi on 2, it's 0. The x coordinate down there is 0. So we're already making some good progress. Okay, this is the unit circle, so my first goal is going to be in these 3 angles. I want to find the coordinates of these, which are cosine and sine. So remember, this is cosine of the angle and sine of the angle, because it's the x coordinate and the y coordinate. So I'm just going to write these down from my unit circle. So in here, I'm really looking for what's cosine of pi on 6. Go over to my exact value triangle. Cosine of pi on 6 will be adjacent divided by hypotenuse, so √3 on 2. What's sine of pi on 6? Opposite over hypotenuse, a half. Keep going around. My angle's pi on 4. What's cosine of pi on 4? 1 on √2. Okay, if you want, you can write it as root 2 on 2. What's sine of pi on 4? 1 on root 2. And then finally, for pi on 3, what's cosine of pi on 3? That's a half. What's sine of pi on 3? That's root 3 on 2. So I've completed that first little part of my unit circle, which is useful for finding trig ratios of angles greater than pi on 2 radians. The question is, well, how am I going to find these other angles around here? How am I going to find, for example, cosine of 5 pi on 6 to put in here when I can't draw a triangle with 5 pi on 6 and use trig rules, because I know my trig rules only work for 90-degree triangles. I'd have some triangle like this with 5 pi on 6 and it's too confusing. So the way I can find something like cosine 5 pi on 6 to find that x-coordinate is just to use some symmetry. So if you see these two triangles I've drawn, they're symmetrical, okay, and they're congruent. So it's the same triangle, just placed in a different area of the unit circle. So what that means is that this height here is going to be the same. So I can put a half here. Okay, and this distance, this horizontal distance in the x-coordinate is the same as well, but the only difference being that this one is on the positive x-axis, whereas over here we're in the negative x-axis. So negative root 3 on 2. So just by using that little bit of symmetry, I now know that cosine 5 pi on 6 is minus root 3 on 2, and I know that sine 5 pi on 6 is a half, and just for fun, I know that tan 5 pi on 6 is y coordinate divided by x coordinate, so a half divided by minus root 3 on 2. That's it, just using symmetry. So we can extend this idea of symmetry further, and I can draw the same triangle with this same little angle here down at the bottom in quadrant 3 and in quadrant 4, and I can do a similar thing because this little angle that we see in all of these sections here is pi on 6, so it's allowing us to use this symmetry. So again, the x-axis coordinate at this point of 7 pi on 6 is going to be the same, minus root 3 on 2. The y coordinate will be the same but negative. And then finally over here we can use any of these symmetrical things around here. This will be root 3 on 2 and minus a half. Okay, that's all it is, just using symmetry. The key thing to understand is that cosine of these four angles all has the same value as pi on 6. Just some of them are negative, like these two, and this one's positive. That's the key thing to think about. I can do the same thing and work my way around the triangle using all of these different symmetries around there. So I'll do one for all the pi on 4 angles. It'll look something like this. And then you can do a similar one for all of the pi on 3 angles too. There it is. There's our unit circle complete. We can now essentially find sine, cos, and tan of all of these angles just by recognizing that symmetry, which is the hardest part of the unit circle to understand. So I'd probably press pause on this and just have a look again at the unit circle diagram. This is the unit circle diagram to get an understanding of that symmetry, which we'll be using all the way through this trig course. Unfortunately, you won't have time to construct this massive diagram every time you want to find, say, cosine of 11 pi on 6. So we need to just come up with a little process for how to do this. So the first thing we'll need to do is just figure out what sign, either positive or negative, these ratios will have in the 4 different quadrants. So if I look at sine, so just looking at the y coordinates, I know that in the first quadrant, all the y coordinates are positive, so sine would be positive. In the second quadrant, they're all positive. In the third and fourth quadrants, they're all negatives. I can do the same thing with cosine. Okay, in 1 and 4, the cosine x coordinates are positive, and these ones, they're negative. Tan is a little bit trickier because it's y divided by x. So in the first quadrant, it's positive divided by positive. Value in the second quadrant, it's positive divided by negative, which will give me a negative. Down here, negative divided by negative, which will give me a negative. And the final one, positive divided by negative, will give me a negative. Correction, this one's negative divided by positive. That'll still give me a negative there. So this will just give me an idea whether the ratio is going to be positive or negative, whether the number is positive or negative. And I can summarize this into that in this quadrant, all of the ratios are positive. In this quadrant, only sine is positive. In this quadrant, only tan is positive. And in this quadrant, only cosine is positive. Okay, that's where we get the cast diagram from, and you'll use that in finding these ratios. So we'll use that idea to try and find the exact value of sine 5 pi on 4. And we can follow these steps. If you understand the process, you can just do it your own way. These steps tend to help out some people. So I'll draw a circle with the x and y axes. So this thing, I've done step 1. Label the quadrants anti-clockwise with quadrant 1 ASTC. Yep, done that as well. Using the positive x-axis as 0, draw the angle in the correct quadrant. So I know this is 0 radians, I know this is pi radians, so 5 pi on 4 radians will be out here somewhere. Okay, done. Determine the size of the angle between your angle and the nearest x-axis. So this is my nearest x-axis. I need to find what's this angle in here. To find this angle, it'll be 5 pi on 4, take away pi. Okay, which is pi on 4. So that small angle in there is really pi on 4 radians. Done. So determine whether the value will be positive or negative using the cast diagram. So I'll look at my cast diagram. You'll see it's in the quadrant where I have a t, where only tan is positive. So I know the sine value here is going to be negative. Okay, and I know its value is going to be the same as sine of pi on 4. Okay, just using that symmetry that we looked at in that massive unit circle diagram. Okay, so I know it's negative, write the sign next to the ratio of the acute angle. That acute angle is this little small angle here. And then my last step, find the exact value of the acute angle using an exact value triangle. So it's pi on 4, so I better use my pi on 4, 1 root 2 diagram. Sine pi on 4 will be opposite over hypotenuse, so it'll be minus 1 on root 2. Yeah, that's all you need to do. So sine 5 pi on 4, I can check this works on that unit circle diagram. So I'll find 5 pi on 4, and I'm after the y coordinate, minus 1 on root 2, exactly what I got. And what we really did in that process was think, all right, 5 pi on 4, I know it's going to be negative because I'm in this quadrant where all the y coordinates are negative, and I know it's going to have the same ratio as pi on 4. Okay, so all we're really done in that process on the next page is take this 1 on root 2 and make it negative because it's 5 pi on 4 is down in this quadrant. That's all it is. So now you have the skill so that when you're walking down the street and someone asks you what's cosine of 11 pi on 6, you can just draw your diagrams and go ahead and do it. Yeah, there is just one case that doesn't really work for that sort of this process, is when the angles lie exactly on the axis. Okay, so suppose I'm trying to find sine of pi on 2. Followed the steps in the previous example, I'd have pi on 2 up here, and then I'd be trying to find what's the distance to my nearest x-axis, the 90 degrees both sides, which quadrant am I in? Well, I'm not in a quadrant at all. So what we do instead is just use a simplified unit circle diagram to be able to find these ratios. So I'll just mark where pi on 2 is, and I'd write the coordinates of these points. There, you'll get good at using these points. And so if I want to find the value of sine pi on 2, I'd draw this diagram on my paper. And knowing that sine is the y-coordinate, I'll just identify that the y-coordinate here is 1, and I'll write it down. So this 1 came from there. Alright, what about another example? So suppose I'm trying to find cosine of 3 pi on 2. I know that 3 pi on 2 is down here. Okay, again, it's on the axis, so I can't use that other method. I know cosine is the x-coordinate. I see the x-coordinate at this point is 0. I'll put a 0 there. Okay, and the only other one that gets a little bit tricky is tan. So say I'm trying to find tan of pi. I know that pi radians is over here. So tan of pi I know is the y-coordinate divided by the x-coordinate. Okay, so the way I would go about doing this is y-coordinate is 0 divided by x-coordinate of -1. It'll give me a tan value of 0. Okay, from this point. Alright, so it's a pretty big lesson, but a really important concept. Make sure you definitely practice all of these so that you're really good to go when we start trying to solve trig equations.